Okay, we're going on to the second box on the first page. We're looking at the other log properties for multiplication, division, and exponents. So these are other log properties. Let me just write what they actually are. So the first one, this is log base whatever of m times n is equal to log base a of m plus log base a of n. So plus. So, okay, the kind of cool thing about log is it takes multiplication, right? A log of a multiplication, changes it to addition. That's the first property. Second property is similar for division, changes it to subtraction. And these should actually be pretty intuitive to you if you think about it, because you know when we deal with exponents, right? When you divide exponents, then you subtract the exponents. When you multiply exponents together, or like two bases with the same exponent, then you add them together, right? And then similarly, last one is the exponent. So if I take log base a of m to the, I'm sorry, m to the k, yeah. Whatever this exponent is, I can think of it as being a multiplier instead. It changes exponent to multiplication, k times the original log base a. So each of these has an exponential counterpart. If you think to the exponential functions, let's see, a to the m times a to the m. Oh, sorry, n, I mean. N, give myself a little more space. A to the m times a to the n is equal to a to the m plus n, right? Right, you guys remember that from laws of exponents? Yeah, and that just follows from the definition of what an exponent is. It just means you multiply it a bunch of times. So this is how many times you're multiplying it together. And similarly, if you have a to the m divided by a to the n, well, that's equal to a to the m minus n, right? It takes this division and it changes the exponents to subtraction, right? And then also for the power, so a to the m raised to the k power, well, that's equal to a to the k times m. Right? You change the exponent to a multiplication. A similar idea here, right? For each of those three. And if you look at the proof for each of these facts that we looked at for the logs, they're kind of just based on these ideas, these principles. So we're gonna change things to exponents and see that the rules of exponents sort of carry us through to the end for each of those identities. Yeah. The book actually gives a proof for the first one, so maybe let's do a proof for the second one. We'll just kind of think through it. I didn't really plan this out exactly, so let's kind of just think through it. We're trying to prove number 2, that log base a to the m over n is equal to log base am minus log base a of n. So the division, the log of the division should be the difference. Okay, let's see if we can do this. So let me just list some facts that I know. I know that, well, let me actually just give a new name to this part and a new name to that part. So let's call it, the book they use R and S, so let's use R and S. Let's let R be equal to log base a of m, and S we'll call log base a of n. All right. So what do I know about exponents? Let's think about the definition of an exponent, of a log. Log says a to the r is equal to m then, right? That's what a log, this equation means in terms of log. A to the whatever's on the other side of the equation is equal to this value. So a to the r is equal to n. And I know also a to the s is equal to n. Right? A to the s equal to n. That's what the log means. Okay. Well then, what I want to do is I want to start from one side and get to the other side, one way or another. Let's start from the right side. Okay, so, or let me start with what I know about exponents. So, how about this? How about, what's m over n? M over n is equal to a to the r over a to the s, right? Which is equal to a to the r minus s by rules of exponents, which is equal to, yeah, a to the r minus s, right. And let's see now, how do I write that as a log? Okay, I see. So this is true, right? This is just rules of exponents. Now let's just apply logs to everything. So let's write the same equation just with log now. So log of m over n is equal to log of a to the r minus s. Right, looking at this left side and this right side. Okay, so let me just copy that down. Log a to r minus s. What does that mean? Log base a. Right. Okay, here we go. So then now we can apply the inverse property, right? This is a to the a to something, right? And this a is going to undo that a, so I end up with just r minus s. So there that is, we're done. Because remember, r is log base a m, s is log base a of n. Kind of out of space here. So let's see, how should I write this? I'm going to just repeat this whole line I wrote at the end. I'm just going to write it on the top here on the left. And just kind of simplify. I'm going to take this part here and just rewrite it here. So log base a of m over n is equal to r minus s, right? This part is equal to that part. And I know r minus s is just log base a of m minus log base a of n. So there, we finished proving what we wanted to prove. All right, this is just a theoretical justification for what we're using. And you don't have to actually know this part, but you will have to, I will ask you eventually to prove something sort of related, but that will be for next class, I think. This class, don't worry about it. All right, let's try the problems. Let's try the problems. All right, we're on number 6. Log base 2 of 3 plus log base 2 of x. Let's do the first 3 together. Log base 3 of x minus log base 3 of 2. And then number 8. Log base, 2 log 4. Base 4 of x plus log base 4 of x minus log base 4x minus 1. All right, all we're doing is just applying the rules that we just learned. So the first one, you can change addition back and forth with multiplication, right? The theorem is stated the opposite direction, but same thing. This is just log base 2 of 3x. Yeah, the sum of the two logs with the same base, you take addition, change it just to multiply log of the product. That's it. Is that okay with you guys? This is using the first property we just talked about, property 1. Or just going in the backwards direction, yeah?
Okay. For this class, will the bases always be the same, like how they're 2 in this one?
They have to be the same in order for us to do this.
Yeah. All right.
Yeah. So this one works too because they're both 3. If one is 3, one is 2, then we can't combine it like that. There are some other things we can do, but we'll learn it in the next class. Okay, so this one, same idea. It's going to be log base 3 this time, and you just divide, right? Subtraction changes to division, so log base 3 of x over 2. So subtraction becomes division and vice versa, right? Division is inside the function, splits out to 2 subtracted logs. All right, the last one, same idea. This time we have addition and subtraction. So, we also have this 2, right? So this 2, first thing I want to do is bring this 2 inside. So this is going to be log base 4 of x squared. You guys see that? Multiplication becomes an exponent inside, yeah? And let me just write the rest. Log base 4 of x minus log base 4 of x minus 1. So now I have an addition and subtraction that's going to become multiplication and division. So it's going to end up with log base 4 of x squared times x is x cubed. Let me do it one step at a time. This is x squared times x over x minus 1, which is x cubed on the top. Log base 4 of x cubed over x minus 1. So this is your answer here. Did you guys get that? Yeah. Okay, ready for the last two? Waiting for you guys to. You guys ready? Nico? Julian? Yeah. Dawkins, are you guys good?
Yes.
Yeah, okay. Okay, let's go. All righty, last two questions, 9 and 10. You write the expression in terms of logarithms of single variables or numbers. Okay, all that means is you're just gonna separate it out, just expand the thing out. So it's log base, and we're going the opposite direction this time, yeah? Log base 3 of 2x y cubed. Let's just do one at a time. All right, so we have a couple things going on. Let's deal with the multiplication first. So this is going to be log base, multiplication, remember, becomes addition, right? It's log base 2 plus log base 3 of x. That's the next one. 2, and then x, and then log base 3 of y cubed. Okay. And then what we want to do is just bring 3 outside, and then we'll be done. So that's equal to log base 3 of 2 plus log base 3 of x plus plus 3. This 3 becomes a multiplier. Log base 3 of y. That's it. It's done. Okay with you guys? Applying all the rules together, yeah? Or just 2 of them, first rule and the last rule. Okay, last question. So we want to do the same thing. This time we're starting with log x squared y squared over the square root of x.
I think it's Z.
What's that?
It says Z on mine.
Oh, it says z?
Yeah.
Oh, yeah, sorry. I can't see. Okay, log of x squared y squared over square root of z. So this is another example of that notation that the book uses, right? Where this is actually log base 10. Well, we'll just write log because it doesn't really make a difference what the base is. The idea is the same regardless of the base. You could have put an L in here, you could have put a log base 2, and either way it's going to split up into separate logs like this. The first split, I'm going to take the product is going to give me a sum of logs, right? It's log base 10 of x squared plus y squared, and then minus z square root of z. Okay, but I'm going to take one more extra step to change square root of z to a half power instead, right? Because square root is really just z to the half power, right? I'm almost done. Last thing is just to pull the exponents out. Pull the exponents out gives me log base, 2 log base 10 of x plus 2 log y minus 1/2 log z. And that is it. That's your answer. Beautiful. So we actually applied all 3 rules this time, right? We did the multiplication to addition and division to subtraction. And then from here, we pulled the exponents to multipliers in the front. And that is it, guys. It's 9:45 now. I'm going to stop the video.